Okay, we are continuing with organic chemistry. The last lesson we spoke about the alkenes. We spoke about the alkenes, which we said that the suffix of these alkenes is ene. We just decided to call it according to our language. It's ene, so that we do not make mistakes when we write. Right? We spoke about alkenes. We spoke about different characteristics of the alkenes. We said that the alkenes, they have got double bond. They are called alkenes because of having double bond. If they do not have a double bond, we will not call them alkenes. These ones specifically, they are called alkenes. Why? Because of double bond. It is the only organic molecule which have got double bond. Whenever you see double bond between carbon atoms, just know that we're talking about the what? The alkenes. I told you that when we give the nomenclature of these alkenes, we need to indicate the position of the carbon where there is a double bond. And I gave you an example, like, let's say we have this one. We have this one. You want to give its name? It's an alkene. Why am I saying this one is an alkene? 1, 2, 3, 4, 5. No. We know that carbon can only bond with or accept 4 electrons, right? Meaning it can only create 4 bonds. So we have 1, 2, 3, 4. So we know that we cannot have 5. It is impossible. Because carbon can only bond with what? How many? 4. So here, by mistake, I drew the 5th one. And I knew that it is impossible. Carbon can only accept how many electrons? 4. Can create 4 bonds. So this is an alkene. Why am I saying it's an alkene? Because they've got double bond. Whenever you see a double bond, just know that we're talking about what? An alkene. So now, here, let us give the nomenclature of this one. What do? We count the number of carbons in the longest carbon skeleton. What is a longest carbon skeleton? A longest carbon skeleton is the linked series of carbons, right? Linked series of what? Of carbon. So we have 1, 2, 3, 4. We have a series of 4 carbon, right? What do we call 4 carbon? We call them what? We call them bute. So it means we're going to write bute. Then we need to indicate the position of the double bond. Right? And in which position is the double bond? It's at carbon number 2, right?
Yes.
Starting from both sides, 1, 2, 1, 2. So it means we'll have to choose 2. If ever we started from this side and we find that double bond is at carbon number 3, and when we start this side we find that double bond is at carbon number 2, we will choose to start this side so that the double bond can be in the carbon, which we will write as a small number, right? So here they are equal. It's 2 from both sides. So it means we have to say 2, then we write N. So this one is bute 2N. Why are we writing it like this? So that when a person comes and draw this one, they will draw this one exactly. If we were to write that this one is butene, someone will draw something different. Look at this one. 1, 2, 3, 4. Do you see this organic molecule? Do you see it? Is it not a butene? It is not a butene. But is it the same with this one?
No.
They are not the same, right? This one is what? Built one in, right? Meaning that the nomenclature of these things, it is very important so that when you draw exactly the one which is needed. Because it is possible for you to draw a different one. So that's why we need to indicate where the double bond is. These two represent where the double bond is, right? You remember we started by the alkanes. The alkanes, what is their characteristics? They have got single bond. They've got single bond. Listen, guys, these things, they've got the characteristics, they've got something which makes it to be different from the others. You understand? It's like when we say we're able to know that this one is a woman, right? This one is a man. We're able to do that because there are certain things which we look and we are able to conclude that this one is female, this one is male, right? The same applies to these things. You won't make a mistake. Whenever you see double bond, just know it's what? Alkene. Is it okay? Okay. Remember I've showed you the alkyl group. Do you remember? Do you remember what an alkyl group is? What is an alkyl group? Huh? These are branches. The alkyl groups, these are what? Branches, right? The alkyl groups, these are branches. So I may not give an example with the branch there because I've already told you how we get to name the branches. We're still learning on a background level. There's going to be a time where we are going to flow at an upper level, right? Yeah. Okay, let me teach you the third one. And this third one is called the alkyl. The alkyl. The alkyls group. I didn't write properly. We call them the alkynes. Alkynes. What do we call this one? The alkynes. We call this one the alkynes. Their suffix. The suffix of the alkynes is yin. It's yin. The suffix of the alkyne group is what? Yin. Remember we spoke about the alkane. We said the suffix of the alkane is what? Ane. The suffix of the alkenes is N. Now we're talking about the alkyne, which is yin. They are different, these homologous series, right? Yeah. Now today we're talking about the what? The alkynes. The alkynes. Their suffix is called yin. It is called yin. What is their characteristics? What are their characteristics? Oh, they are unsaturated. Who can tell me why are we saying they are unsaturated? Why do we say that these ones they are unsaturated? Give me an answer, Miranda. Because they've got more than one bond, right? They are unsaturated because they've got double bond or triple bond. Double bond or triple bond indicate being unsaturated. Why do we say that the alkanes are saturated? Because they've got what? Because they've got single bond. Single bond talks about saturation. So whenever they have double bond, triple bond or whatever, it means they are unsaturated. So these ones, they are unsaturated because they've got triple bond. They've got triple bond. They've got what? Triple bond. Whenever you see triple bond, just know that this one is an alkyne. This one is an alkyne. Whenever you see the what? The triple bond. Whenever you see the triple bond, Just know that this one is a what? It's an alkyne. Is everything okay? Everything is still moving smoothly, right? Okay. The characteristics of the alkynes is that they are unsaturated, right? They've got triple bond. Here is the structure. Can you see that? Can you see that? What is the name of this one? 1, 2, 3. How many carbon? What does 3 carbon mean? Huh? Prop, right? Don't confuse prop with pent, because they start with P, all of them. Pent is 5 carbon. This one is prop, right? What is the suffix of these ones? But we need to indicate the what? The position of the triple bond. So the triple bond is at carbon number 1. So this one is prop 1E. So actually it's propene. This one is what? Propene. You understand how we give the name of these things? Okay. Can you see here that we have 4 bonds? Carbon can only create 4 bonds because it is in short of 4 carbons, right? So 1, 2, 3, 4. This carbon. You want to have the hydrogen coming out from here because we know I showed you the valence electron of carbon, right? It is in short of 4. This one. Understand? It is in short of 4. So we call this one the alkyne. The alkynes, right? Okay, let me just give you another example of the alkynes. Here it is. Guys, are you getting the story here? But you are getting it, no? Yes. Just simple, just need to relax, then you will get it. Can we be able to give the nomenclature of this one? Let's count how many carbons? 1, 2, 3, 4, 5. It has got 5 carbons, right? How many carbons? It has got 5 carbons, eh? What do we call 5 carbons? Pent. So this one is what? Pent. But it's a pent, eh? Yeah. Isn't it? We said the pent is tab, right? Yes. So it's pent, this one. So where is the triple bond? Where is the triple bond? The triple bond is at carbon number 2. Look at this. 1, 2. Okay? Look at this. 1, 2, 3. It's either we start from this side or we start from this side. But what does the rule say? We need to start from the carbon, which will give us a smaller number, right? So when we start from this side, we're going to say 1, 2. It means double bond is at carbon number 2. When we start from this side, 1, 2, 3. So we are bound to start from this side so that we can write the what? The smaller number. So it means we're going to have pent 2E. You understand? We have got the what? Pent 2E. Is it difficult? It's not? Okay, guys. I want us to continue. We just spoke about the alkynes, right? Now I want us to continue. We were supposed to move to the 4th homologous series. We're supposed to move to the 4th homologous series. But I just want to take you back to the alkanes. There are some special types of the alkanes. It's another homologous series, but it have got the components of the alkanes, right? And this one is called haloalkanes. These ones, what are they called? They are called haloalkane. They are called the what? Haloalkane. It's like we are greeting alkane. Hello, alkanes. It's like you are greeting the alkanes. It's called haloalkanes. You get it, no? Yes. It's called haloalkanes. Haloalkanes. Why do we call it haloalkanes? It is a mixture of a halogen and alkanes. It is a mixture of what? Halogen and the alkanes. The question is, do you know the halogen? This one is a halogen. This one is a alkane. Do you know the halogen? If you take your periodic table, right, and you look at group number 7. Group number 7. You get it, man? All of them, that column, do you see that column? That column, we have the what? The halogen. The first halogen that is there is what? Is fluoride. This is group number 7, where it is written 17 at the top. We call it group number 7. We just remove the 1. Right? The first halogen is what? Fluoride. The second one is what? Chloride. The third one is what? Bromine. The fourth one is, we call it iodine. Not iodine. We call it iodine. The fourth one is iodine. Then we've got what? The one which is written 80. Can you see it? Huh? It is also what? A halogen. It is a what? So it means that the haloalkanes is a mixture of what? Of alkanes and then halogen. What are halogens? These ones, fluorine, bromine, iodine, etc., etc., and 80. You understand? We call them what? Halogen. They are called the what? Halogen. So I want us to speak about the haloalkanes. Why do we call them haloalkanes? It's because it's the mixture of what? Halogen and then alkane. Halogen and then alkane. Look at this one. Do you see what I have there? Do you see what I have? Yes. Can you see what I have? I have Cl, right? What does Cl stand for? Chloride. So is this not an alkane? It's an alkane because it has got single bond all over, right? Yes. And we see a halogen. Can you say halogen? Yes. Listen, you won't have anything else other than a halogen. I know some of you are going to write different things. Oxygen will be here very soon to you. Whenever we will introduce oxygen, it won't be something like this, you'll see. So these ones, they are called what? Haloalkanes. Haloalkanes. Because they've got an alkane and a halogen. So I want to show you how we give the name of this one. According to the exam guideline, they say that an alkyl group should be prioritized than a halogen. It's just that on this one we don't have an alkyl group. No? Okay. So, this one, let us give it a name. It is 1, 2, 3. What is the name of, what do we call 3 carbons? Pro. So it is propyl. Right? So since it's an alkane, what do we call it? Since it's an alkane, what do we call it? We call it propane, right? We call it propane. Now we want to give the name, the nomenclature of the chlorine. How do we include it? We need to indicate where the chlorine is, right? Chlorine is on carbon number. So this one we're going to call it 2. Don't forget this. 2-chloropropane. That one it is called 2-chloropropane. It is called 2-chloro. The chloropropane must be what? One word. Let me write it properly. This one will just indicate the position of the iodine. It is on carbon number 2. This one is 2-chloropropane. This one we call it chloropropane. Let me just add. You see what I have there? You see what I have? I have the fluoride. Can you see it? I have a fluoride. Can you see it? How do we give the nomenclature of this one? Let us give it. Let us count the longest carbon chain. The longest carbon chain is the what? The longest series of carbon. The carbons that must follow each other, right? Yes. And to follow each other, so let the carbon. So, okay. Let us count. 1, 2, 3, 4, 5. Oh, we have 5 carbons. What do we call 5 carbons? Pent, eh? Yes. Pent. We can see that it's a haloalkane. How do we see? Because it has got the halogen, right? And single bonds. Can you see? So this one, it is what? Pentane. Then let us give the position, the nomenclature of the fluoride. Where is the fluoride? 1, 2, 3. 1, 2, 3. Fluoride is at carbon number 3. So it means we're going to say 3 fluoropentane. You see how we give the name of this one? 3 fluoropentane. This fluoro and pentane, they must combine. Pentane. 3 fluoropentane. 3 fluoropentane. That is the name of that one. Do you get it? But look at, let me just introduce something which is complicated to you. I added another F. Can you see? I've got 2 fluorides. Listen, when we have chloride, we call it chloro. When we have fluoride, we call it fluoro. When we have iodine, we call it iodo. When you have a bromine, you call it bromo. Right? When you have bromine, you call it bromo. You just call it omo, all of them. You understand? Chloro, fluoro, iodo, bromo. You understand? Write these things. Chloro. And to write chloro in terms of spelling, it might beat you. Even fluoro, it's fluoro. Fluoro, chloro, bromo, iodo. You hear me? Fluoro, chloro, iodo, bromo. You got it now? That's how we give the names of these things, right? Chloro, bromo, iodo. Okay. So now, let us give the name of this one. It has got 2. Can you see it has got 2? Let's count. the longest carbon chain. 1, 2, 3, 4, 5. It's 5, right?
Yeah.
5 is what? Things we love. It's pants, man, not bread. Pen. Things we love, right? Pent. So this one is what? Pentane. Pentane, right? Then what do we do? We need to indicate the position of the what? Of the halogen, right? This one is 2. This one is 3. Let's see. 1, 2. This one is 3. This one is 4. Which numbers are smaller? Can we start from this side or this side? This side, right? Because we'll have 2 and 3, right? Rather than to have 4 and 5. So this one we're going to call it 2,3. How many fluoro do we have? 2, right? It means we're going to call it 2,3 difluoro. 2,3 difluoropentane. Because there are 2, we call it what? Di. Di means 2. You learned about it, disaccharide. You remember the disaccharide? The monosaccharides, when you were learning about sugars. You remember? In grade 10. Di means what? 2. For instance, if there were 3, we're going to call them what? Tri. If there were 4, we're going to call them tetra. Remember, we did these things last year. You forgot tetra. When I've got 4 bonds, you forgot that thing which we did. When we were learning about bent, angular, etc., etc. You forgot? 4 means tetra, right, my babies? 4, it means 2 is di. 2 is di. 2 is di. 3 is what? Tri. 4 is tetra. So if we have 2, right? It means we are going to start by what? Di. Listen. If we have 2 of the same kind, if we have 2 fluoride of the same kind, we call it what? Di. Mashitan? I know, because you are going to call it di when we have fluoride and chloride in the same alkane. And it's going to be wrong. We call it di because there are 2 fluoride, right? Okay. Did you get it? Okay, let me show you something. Can I show you? Okay. Do you see this one? Can you be able to give the name of this one? How many carbon? 1, 2, 3, 4. It has got 4, right? Yeah. What do we call it? Or what do we call 4 carbons? Boot. It's a boot, right? Boot. Then is it a butane, right? We're going to call it a butane. It's a butane. You agree, most? Then now we give the name of the what? Of the chloride. The chlorides, right? Okay. How do you call this one? How do you give the nomenclature of this one? We count that chloride is on carbon number 1. 1, 2, 3. 1, 2, 3. Then we have to use 2 and 3. Can you see that at carbon number 2 have chloride? Yeah. Even at carbon number 3, can you see we have chloride? Yeah. Then it means this one we're going to call it 2,3 dichlorobutane. 2,3 dichlorobutane. Do you understand why are we calling it dichlorobutane? Yes. You understand the reason we're calling it dichlorobutane, right? Yeah. So that's the reason. We're moving forward, right? We're moving forward. I want to just show you something new. Can I show you? I want to show you something new. I want to remove one chloride. Then, let me write a bromine. We have a Br. Can you see what we have there? Hey, it's a problem. Can you see? Look, we have Cl and Br. Yeah, it's tough. Are we going to call it a di something? This one? No. We can't call it a di something, right? Yes. There are two, but it is different names, right? Yes. There are two, and it is different names. There are two, but it is different names. So, let me show you what we call this one. How many carbons? 4 carbons. Can you see that? Yes. So, 4 carbons, we call them what? We call them but. So, it's going to be butane, right? Okay. So, now, we have Br and Cl, bromine and chlorine. Huh? So, what do? When we give the names of these two, we do it according to the alphabetical order. We start alphabetically. Between B and C, which one comes first? B. So it means this one we're going to give B a preference. We're going to give B a what? A preference. It means we're going to start from this carbon where B is. So it means we're going to indicate, we're going to write it as 2, right? 2 bromo. 2 bromo. Do you see that? Yes. Then we're going to have what? 3. Is it 3? 3 chloro. So this one is 2 bromo, 3 chloro butane. Okay, we've just spoken about the haloalkanes. We spoke about the what? The haloalkanes. Do you see the rule? Do you see the rules which we use to give their names? If we have got 2 of them, what do? We use the alphabetical order. The same way in which you name a hurricane. You remember they are named the alphabetical, right? Yes. If we have got, if the last one started with B, it means the next one will start with C. You see, I know geography. Okay. Then, let us move. I want us to talk about another homologous series. This homologous series is not the hydrocarbon. Halogen, hydrocarbons. Halogens, I mean the haloalkanes, are they hydrocarbons? They are not hydrocarbons because a hydrocarbon is a what? A compound that contains carbon and hydrogen only, right? Okay. I want us to learn about this one. Hey, that's very important, these ones. But Nico loves them too much, these ones. Right? I want us to learn about homologous series that is called the alcohol. The alcohol. This one is called what? Alcohol. I want us to learn about the what? Homologous series which is called the alcohol. Alcohol. They are called the what? Alcohol. They are called what? Alcohol. Before we talk about the alcohol, I want us to exhaust this definition. Functional group. I want us to exhaust that definition of what? Functional group. Okay. I want us to exhaust the definition of functional group. This definition is examinable. You must know it. It's very important. I told you that organic chemistry has got many definitions. Right? So a functional group It's a what? Let me start here. It's a bond or a group of atoms. It's a bond or group of atoms that determine, we call it determine. It's determine the physical and chemical properties of group of organic compound. What are functional groups? It's very short. It's what? The type of a bond, right? Or group of what? Atoms that determine the chemical and the physical properties of organic compound. It is very short. You'll understand. What do I mean when I say it is very short? Look, remember that we spoke about the alkanes, right? How do we know that they are alkanes? Because they've got what? Single bonds. So they've got unique properties because of the type of bonds which they have, right? We spoke about the alkenes. You remember the alkenes? Yeah. How do we know that they're alkenes? Because they've got what? Double bond. So it means that double bond, it gave it its unique chemical and physical properties. So that's why we call that functional group. Functional group is a what? It's a type of a bond, right? Or a group of atoms which gives what? Organic compound their unique chemical and physical properties. You understand? Do you understand that? Is it difficult to know? Even by now, you know it. These are what? Look about a group of atoms that are talking about the compound. Remember I told you that in physics, we refer to an atom, we use the word atom to refer to a group of elements. Do you remember? We use the word atoms while we are referring to one element. So, the functional group is a what? Bond or a group of atoms that determine the physical and chemical properties of the organic compound. It is an alkane because they've got single bond, it is saturated. It has got unique properties. It is an alkene because they've got double bond. We call those double bonds the what? The functional group. So now, I told you that I want us to talk about the what? Alcohols. You must know this definition. Alcohols. What are the properties of alcohol? It has got a functional group. It has got a what? A functional group which is OH. OH is coming back. Do you know OH? What do we call OH? We learned about this in grade 11 when we were talking about acids and bases. What do we call OH? Hydro? It's a hydroxyl, right? Hydroxyl group. Alcohol, they've got what? What do they have? OH. Whenever you see OH, it means that thing will become a what? An alcohol. How do we know that it is an alcohol? It has got what? OH. It has got a functional group. Its unique chemical properties are given by the presence of what? OH. Let me give you an example. Before I give you an example, I haven't said anything. Right? The suffix of alcohol, it is called ol. The suffix of alcohol, it is called what? Ol. It means every alcohol, its ending name must have an ol. Ol. You hear me? Things that Sbongile love too much. Can you see, right? Yes. The alcohols. Their suffix is what? Ol. The ending name, right? Let me just write something here. Because this one, well, starting from this one, then we must add. We must add a n to the name of the longest carbon chain. What must we do? We must add. If it have got two carbon, what do we call two carbon? Two carbon, what do we call them? Add, right? It means we're going to call it what? Ethan. Isn't it we're going to add the AN? We add the AN to the longest carbon chain. I told you that I was not supposed to even write this. This is not physics, does not exist. Even when I show other scientists this thing, they will laugh. Because this thing does not make sense, right? I'm just writing it because it's you. Because, hey, you are unpredictable. Confirm. So that I'm writing these things which do not exist. For the sake of your understanding. Okay, what do I mean? Let's say I have this one. It has got what? An alcohol, it has got what? It has got a functional group of what? OH. What is the name of this one? What is the name of this one? It's an alcohol. The name of this one is a what? It's an alcohol. Why is it an alcohol? The presence of what? Hydroxyl group OH. The presence of hydroxyl group OH. So let us give it a name. Let us count the longest carbon chain. 1, 2. It has got how many? How many carbons? What does 2 mean? 2 means what? 2 is earth, right? I told you that we add what? AN to the longest carbon chain name, right? So this one is going to become a ethan, right? But it is going to become ethan. But I told you that the suffix of what? Of alcohol is what? It's all. So it means this one we are going to call it ethanol. Starting from this one, we add the AN. It means every name we must start by the what? AN. Then we have what? The suffix. You understand? So this one is what? Ethanol. Ethanol. But that's not how we are supposed to name it according to the exam guideline. We need to indicate where the double bond, and not double bond, where the functional group is. It means this one is going to be called ethan, then 1 ol. It's called ethanol. It is called ethanol, yes. But we're just indicating where OH is, hydroxyl group, right? Listen, a question can come and ask you, what is the functional group? What are the functional group of alcohols? What is the functional group of alcohol? What is the functional group of alcohol? It's OH, right? What do we call like OH? Hydroxide. Hydroxide. So we need to do what? We need to indicate where the OH is, hydroxide group. You get the story, Mus. Okay. I become happy when you get the story. Okay, let me just give you another one. Okay. One. I want us to give the name of this one. The name of this one. My markers are just disappointing me. But I hope it's visible out there. Okay. Can we be able to give the name of this one? Why is this one an alcohol? Because of OH. We're going to learn about a lot of them. We're going to learn about a lot of them. Tomorrow we are going to learn about primary, secondary, and tertiary alcohol. This one is a secondary alcohol. But I won't tell you now why am I saying it's a secondary alcohol, but I will tell you. 1, 2, 3, 4. 4 carbon, can you see? Yeah. What is 4 carbon? Bute. Right? Yeah. We add, what do we add? AN. It's butane, right? Yeah. The OH is at carbon number 2. 1, 2, 3, or 1, 2. What are we going to choose? 2 or 3? 2. We're going to have 2 all. So this one, guys, is butanol. Butanol. But we need, when we give the nomenclature, we need to indicate where double bond is. So this one is butan 2 all. Is that difficult? It's butan 2 all. I'm going to give you to teach you why this one they've got the alkyl group, the branch, right? And now we're expecting you to write. Do you understand? Yes. Okay. Today's lesson ends here. We're going to talk about ketones. We're going to talk about aldehydes. We're going to talk about carboxylic acids. We're going to talk about ester. Then we stop. We're left with 4 functional groups. Thanks.